So we have Geometry, Module 1, Lesson 1, Explain 2, using the distance formula on the coordinate plane. So the Pythagorean Theorem, if you kind of remember that, works with 90-degree triangles, or right triangles, and states that a squared and b squared equals c squared, where a and b are the lengths of the legs of the right triangle and c is the length of the hypotenuse. You can use the distance formula to apply the Pythagorean theorem and find the distance between 2 points on a coordinate plane. So let's go to the next page and see what this says. Distance formula, and you need to copy it down. This is really important to have in your notes. But if nothing else, the one way things that you want to pay attention to is that it's very similar to the Pythagorean theorem. So where Pythagorean theorem is a squared plus b squared equals c squared, if you square root both sides, you would get the square root of a squared plus b squared equals c. And that's where this distance formula comes in, because the square root of those gives you the hypotenuse, aka c. So this is initially the Pythagorean theorem, but we're focused on that c. And not only that, we need to find this length of my a and this length of my b. But since it's on a coordinate plane, what they're going to be looking at is like, well, if this point here is my x1 and this point here traveled a distance over to be my x2, then the difference between those two x values is in fact my a. All right? So if this x2 happened to be, let's say, 7, and my x1, my x point over here, x, the first point, is 2, then 7 minus 2 means that this length here, or a, is 5. And that's what they do here. This is nothing more than an expression to find a, the distance of change, or that leg of that triangle. And then they do the same thing with b, where traditionally this is a squared plus b squared. Well, b represents the change in my y. The distance from here to here is going to equal my b. So again, if you take y2 and minus y1, that gives you this leg which you need for the Pythagorean theorem. So if y2 happened to be 9 high, and y1 happened to be 3 high, let's just say, then this distance would be 9 minus 3, or 9. And that would give you your b that you would then square and plug into the what would initially be the Pythagorean theorem to find your length here. So remember that. It's not a new formula. It's just written with one extra bit of information, an operation that you need to do in order to find this line segment before applying the Pythagorean rule, which says c equals the square root of a squared plus b squared. All right, so let's move on to our example 2. Determine whether the given segments have the same lengths. Justify your answers. So AB and CD. So you can write the coordinates of their endpoints, AB's endpoints, CD's endpoints, and now we need to find out how long those line segments are. So you're going to plug them in for here. Now, one way that usually works is if this is the x1, y1. This is the x and y of your first point going from left to right. Over here above the b, you can put x2 and y2. This is a quick, easy step and to be able to figure out your information. Okay, so x2 minus x1, and please note that it's a minus even though this is a negative. So it's always important to put this in parentheses. Kind of helps avoid that, oops, I forgot to add that second negative when working with a negative number. So a negative times a negative is a positive, and you square it to get your answer here. Now over here, this is going to be another trick spot that happens to get a lot of people, so you have to want to be conscious of this, is that they did the y2 minus y1, the y of your first point, and got a negative number. If you do not put these in parentheses before you square it, then according to our operations, your calculator will do 2 times 2, or 2 squared, and then multiplied by 1. So you get a negative answer, and that would be wrong. You shouldn't square any number, positive or negative, and get a negative answer, because a negative times a negative is a positive. So make sure you include this inside the parentheses and then square it. So you get 25 plus 4, or the square root of 29. So that's what A is. Can you simplify it? Yes. Do we need to? No. So then you're going to do the same thing with C. You got your x1, y1, x2, y2. Substitute them into your equation. Being mindful to watch your negatives. This equals 2, which I'm going to square. This equals negative 5, which I'm going to put into parentheses and then square. And I get the exact same answer. So AB is the square root of 29. CD is also the square root of 29. So thus, they are the same length. Okay? So EF and GH. So first and foremost, plug in those ordered pairs and those endpoints. So now on your book, you can even do it where you do x1, y1, x2, y2, write it in on top or bottom, doesn't matter. Same thing, x1, y1, the x and y of your first point, x2, y2, the x and y of your second point. Plug them into your formula, pause the video, and try to solve on your own, and then we'll check your answers. Alright, so let's see what you got. So hopefully you substituted that in, being mindful that that's a negative, that's a subtraction, and that's a negative. So a whole lot of negativity going on. And then you would square it. Make sure over here that you are squaring the negative so it's inside the parentheses, and get your answer of 26. Okay. So let's check out GH. So if you haven't finished it, make sure you get it done. Substitute in your pieces. Add, subtract, square, and get your answer. Now if you notice, they're different. So since they're not equal in value, they're thus not equal in length. And there you go. All right, let's look at the next page. All right, so reflect. Consider how the distance formula is related to the Pythagorean theorem. Use the distance formula to find the distance from U to V. You would write UV equals, and explain how 3 minus negative 3 in the distance formula is related to A in the Pythagorean theorem, and how 4 minus negative 1 in the distance formula is related to B in the Pythagorean theorem. So go ahead and think back what we kind of talked about, look at the pictures, think of Pythagorean theorem, and pause the video and write down your answers for that. Okay, so remember, you don't need to have word for word it's more significant to put in your own. We're after the concept. So this is their version of the concept and what it should say, where it is equivalent to A and B, the change and horizontal change and the vertical change. Okay, so number 8, determine whether J, K, and LM have the same length and justify your answer. So go ahead and look at the picture. If you need to write out your distance formula, it's a great practice to practice the formula and to see what you need to plug in where and how. Identify your pieces and solve the problem. Go ahead and pause the video and work this one through. Alright, so let's check your answers. So hopefully you got all your endpoints. You then identified your x1, y1, x2, y2 for each of those line segments. Plug them into your distance formula. Get your answers and note that they are in fact the same. Alright, so explain 3, find a midpoint, as up next. I hope this helped.